Okay, so this is the first video on the deep learning series. In this video, I'll be giving the introduction to what deep learning is and what is the basic intuition behind deep learning. You need not to note down anything from this video. You can just watch and listen to get the feeling of what deep learning is. I'll be not formalizing anything in this video. I'll be just giving the rough intuition of what deep learning is. To get started, I'll start with this particular image and we want to develop an algorithm to classify whether or predict whether this image belongs to a cat or a dog. So let's start with a very simple algorithm. So we can represent this image as an image pixels where each elements of image pixels represents the intensity of the pixel. Okay, a very simple algorithm that we can take over here is that we can take the sum of the intensity or sum of all the pixels. Very simply, if I say if the sum is greater than certain threshold value, then we'll see that this image belongs to a dog. If the sum of pixel is less than a threshold value, we'll see that this image belongs to a cat. So this is a very simple algorithm. In this case, we have taken the threshold value to be 12. Okay, so if sum is greater than 12, then it is dog. If sum is less than 12, then it is a cat. What could be the intuition behind this algorithm? A very simple intuition behind this algorithm could be that dogs are much more darker in color. That's why their pixel intensities might be much higher in values. And cats are more lighter in color. That's why their pixel intensities much be very less in values. That's why we can think of very simple algorithm that can give us a prediction whether the image is of a cat or a dog. You can obviously see certain challenges with this algorithm. This is a very naive algorithm, not very complex algorithm. So there is a very good opportunity or very good chances that we'll be getting very incorrect results in most of the cases. That is the first thing. Second thing is that there is no learning in this algorithm. What does learning mean? I'll try to cover that in the upcoming slides. So this operation that we are doing, that is taking the sum of the pixels, we call this operation as a pooling operation and convolution neural network. I'll be not going into the detail of pooling operation right now because we'll be covering it in detail in the upcoming videos. So for now, you can just hear this and keep this in mind that this operation that we are doing, that is taking the sum of pixels, it is similar to the pooling operations in CNN. There are different kinds of pooling operation like max pool pooling and mean pooling and global pooling. We'll be covering all of them in detail in the upcoming videos. Okay, now I will be adding a bit more complexity in this particular algorithm. I'll be adding the complexity by introducing a new matrix which is a weight matrix over here. So there is a one particular property about this weight matrix that we need to keep in mind, that the elements of this weight matrix are mutable. We can change the elements of this weight matrix. How will it help us? Let us see. So first let us understand the algorithm in brief. So we are having a weight matrix which is this, where most of the elements you can see are 1, only few elements are 0. And then we are having the image pixels. What the first operation that we'll be doing over here is take the element wise matrix multiplication of our image pixel with this weight matrix. And on doing the element wise matrix multiplication, we'll be getting this new matrix which is output matrix. So you can see in element wise matrix multiplication, what we are doing is that we are multiplying this element, that is 1 comma 1 element, with the 1 comma 1 element of the weight matrix. Then we are multiplying 1 comma 2 element of image pixel with 1 comma 2 element of weight matrix. 1 comma 3 image element of the image pixel, we are multiplying that with the 1 comma 3 element of the weight matrix, and we'll keep on doing that to get this final output matrix. Okay, once we have this final output matrix, we'll be again taking the pooling operation, we'll be taking the sum of all the pixels, and if sum is greater than threshold, we'll say it is a dog. If sum is less than threshold, we'll say it is a cat. So this is a bit more complex algorithm as compared to our previous algorithm. So that is first thing. And the second thing that we can say is that here in this algorithm we do have a possibility of learning. So why do I say there is a possibility of learning? By that I mean that, let's say with this particular matrix we got certain results, but results are not very good or not very correct. And as I said in the beginning, that this weight matrix is mutable. We can change the elements of this weight matrix. So what we can do is that we can change the elements of this weight matrix to get much more better performance or much more better result over here. And we can keep on changing the elements of this weight matrix until we get the best results. So there is a possibility of improvement over here. And this is what I mean by the possibility of learning in this particular algorithm. In the terms of convolution neural network, this element-wise matrix multiplication of image pixels, which with weight matrix is nothing else, but we can say this is a convolution operation. What is convolution operation? We'll be seeing it in detail in upcoming videos, but for now you can just understand this as a simple convolution operation where we are doing the element wise matrix multiplication of image pixels with the weight matrix. Okay, going one step further ahead, instead of having just one single weight matrix, let's say now we are having two weight matrix to introduce more complexity in our algorithm. So in the first step, what we'll be doing is that we do have our input image. This is input image. We are doing the matrix multiplication with the weight 1 matrix to get an output matrix over here. So this is the same operation that we did over here. So till this point, everything is same, nothing is changing. Okay. So here till here, everything is changed, same, nothing is changing. Okay. Now we do have one more matrix over here, which is weight 2 matrix. Weight 2 matrix is different than weight 1 matrix, and this weight 2 matrix is also mutable. It is having the same properties as the weight 1 matrix. What we'll be doing now, we'll be taking the element wise matrix multiplication of output 1 with the weight 2 matrix to get an output 2 matrix. So we got the output 2 matrix. We can take the sum of pixels of this output 2 matrix, and if the sum is greater than threshold, we say it is in dog. If the sum is less than threshold, then we say that it is in cat. So just one extra addition that we did over here is that we just added one more layer or one more matrix, which is weight 2 matrix. So you can think of this particular algorithm in two steps. The first step is layer 1. We are doing the element wise matrix multiplication with weight 1. In layer 2, we are doing the element wise matrix multiplication with the weight 2 matrix to get an output 2 matrix. So summarizing what we have done till now, we can think of it, we do now have a deep learning model where we do have two layers, layer 1 and layer 2. Weight 1 matrix is associated with layer 1, weight 2 matrix is associated with layer 2. We'll be giving our image as an input to our deep learning model, which will be doing certain computation in sequence. First some computation will happen in layer 1, then some computation will happen in layer 2, and we'll be getting the final result as cat or dog. So this set of matrices or this set of two layers, this is our simple deep learning model. So this is a very basic explanation of what deep learning model is. You can get some basic intuition or feeling of what deep learning model. It is nothing else, but it is a set of this weight 1 matrix and weight 2 matrix with the set of operations that these two matrices are doing. Okay, now I'll be just spending just a minute on what is biological neurons, how does that works, to relate it with the artificial neural networks. So in biological neurons, what happens is that, let's say we are looking at the visual nervous system. We do have an image over here. This image gets as an input for eyes. So our eyes do have certain neurons. So these neurons will be getting fired up because of this image, and they will be propagating the signal to the higher visual nervous, higher cortical areas, which is, let's say, optical chiasm. From this optical chiasm will be the nerves in this optical chiasm will be propagating signal to much more higher levels of our brains, which is visual cortex, and some more complex operations will be happening in this visual cortex. So this is how our biological neurons works, and the today's artificial neural networks that we are seeing, these are mostly inspired from the biological neurons. Although there are very subtle differences between artificial, there are many differences I would say between artificial neural networks and biological neurons, and artificial neurons are now no longer similar to biological neurons. There are very big differences between both of them. Okay. Okay, so we'll be looking further ahead into more concepts of deep learning in the upcoming lectures or videos. Thank you for now. Bye bye.